Question 5. The height, h meters, of a tree, t years after being planted, is modeled by the equation h squared is equal to at plus b for values of t between 0 and 25, where a and b are constants. Given that the height of the tree was 2.60 meters exactly 2 years after being planted, and the height of the tree was 5.10 meters exactly 10 years after being planted, the first part asks us to find a complete equation for the model, giving the values of a and b to 3 significant figures, and this question's for 4 marks. So here we've been given an equation that models the relationship between the variables h and t for different values of t, and we've been given 2 statements which give us the values of h for exact values of t. So in order to find a complete equation for the model, let's go ahead and substitute these values into our equation and see what the outcome is. Okay, so substituting these values into the equation gives us the following: 2.60 squared is equal to 2a plus b, and 5.10 squared is equal to 10a plus b. Evaluating the left hand side of both equations, or the first one, we get 2.60 squared is equal to 6.76, so we get 6.76 is equal to 2a plus b, which we can just call equation 1. And for the next equation, we have 5.10 squared is equal to 26.01, so this is equal to 10a plus b, which we can call equation 2. Now inspecting this, we can see that we have 2 unknowns, a and b, and 2 equations, and therefore we can solve to find the values a and b by using simultaneous equations by process of elimination. And here we can do equation 2 minus equation 1, which will eliminate the b value, and this gives the following: 8a is equal to 19.25. Dividing both sides by 8, we get that a is equal to 2.40625. It's important we don't yet round to 3 significant figures, as we need to find the complete values of a and b first. So we can then substitute a into any of these equations. I'm going to substitute into equation 1, and we get the following: 6.76 is equal to 2 times by 2.40625, which is our value for a, plus b. Working this out, we get the following: 6.76 is equal to 4.8125 plus b, and subtracting this value from both sides, we get that b is equal to 1.9475. Okay, so now we've found the complete values for a and b. Let's round to 3 significant figures, and so a is equal to 2.41 to 3 significant figures, and b is equal to 1.95 to 3 significant figures. And therefore, subbing these values back into the model, we get that the complete equation for the model is h squared is equal to 2.41 t plus 1.95. Okay. So the exam technique here is that when you're given statements in an exam, especially when you see 2 statements like this, where you can substitute values into an equation, don't hesitate to substitute those values into the equation, because oftentimes you'll end up with a simultaneous equation which you can solve. Okay. The next part of the question says, given that the height of the tree was 7 meters exactly 20 years after being planted, evaluate the model giving reasons for your answer. So in this part, we're now given another statement of fact about the height of the tree after exactly 20 years. We're told that that height is equal to 7 meters. So that's what's happened in reality. And we also have a model which we can use to estimate the height of the tree after 20 years as well. So let's sub in t equals 20 into this equation and see what the height of the tree is. And that would give us a good indication of whether our model is accurate or not. Okay, so subbing t equals to 20 into equation 3, so I've just called this equation 3, we get the following: h squared is equal to 2.41 multiplied by 20 plus 1.95. Working out the right hand side, we get that h squared is equal to 50.15. And if we take the square root of both sides, we get that h is equal to, well, in general would be positive or negative, 7.08 and so on, but we are working in height, which we know is a positive quantity, and therefore h is equal to 7.08 and so on meters. Now, since 7.08 and so on meters is approximately equal to 7 meters, which was the real height after 20 years, well, we can conclude that our model, equation 3, is a good model. So just to try and generalize these types of questions, because they do seem a little bit open for interpretation, whenever you're asked to evaluate a model, they're often looking to see how you're able to analyze the behavior of your model for large values of t, or they're actually looking for you to compare your model with real life scenarios, okay?